Welcome to the Blue Collar Tutor Test Preparation Series for the New York City Fire Department, S-13 Certificate of Fitness for Citywide Supervision of Standpipe Systems, and the S-14 Certificate of Fitness for Citywide Supervision of Multi-Zone Standpipe Systems. It is critical that you understand this material to pass the exam. If you haven't already, it is recommended that you watch the brief overview video at the beginning of this series before moving on to the subsequent volumes. After an initial run-through of the entire series, refer back to each of these volumes, as often as needed, until you are confident with the material covered in each section. Once you become proficient with all of the material in this course, continue on to the S-13 and S-14 practice test sections to test your knowledge of the material. Chapter 8. Standpipe System Components. 1. Roof Manifold. Standpipe systems are used in buildings where it may be difficult for the fire department to pump water on the fire. For example, standpipe systems are required in buildings that are over 6 stories or 75 feet in height. A standpipe system may be combined with an automatic fire protection system. For example, a standpipe system and a sprinkler system may be installed in the same building. The standpipe and the sprinkler systems may even share the same water supply and riser piping. The top of the standpipe riser extends up onto the roof. 3 hose connections are attached to the top of the standpipe riser. These 3 connections make up the roof manifold. The roof manifold is used when extinguishing fires on the roof or adjacent buildings. It is also used when testing the water flow in the standpipe. At the top of the highest riser there shall be provided, above the main roof level, a 3-way manifold equipped with 3 2.5-inch hose valves with hose valve caps. The manifold may be set in a horizontal or vertical position, provided the hose outlets are set back between 18 inches and 60 inches above the roof level. 2. Fire department connection. For automatic standpipe systems, a connection through which the fire department can pump supplemental water into the sprinkler, standpipe, or other system furnishing water for the fire extinguishment to supplement existing water supplies. For manual standpipe systems, a connection through which the fire department can pump the primary water supply to the manual standpipe system at the required system demand. The fire department connection is always installed on the system. The connection is used by the fire department to pump water into the standpipe system. Fire department connections must always be accessible. Each connection shall be equipped with a check valve. An auxiliary source of water supply for standpipe systems includes manually activated fire pumps or fire department connections. A pressure restricting device shall be installed at each hose outlet where required by the installation standard of the National Fire Protection Association 14 and the New York City Building Code. The floor location and pressure setting must be marked on the device. An occupant of the building may be injured if a hose is used when the pressure restricting device is not installed. The pressure restricting device may be adjusted or removed by fire department personnel during an emergency. In some occupancies, only a hose valve is installed in lieu of both a hose valve and hose. The fire department attaches its own hose to this connection when fighting a fire. Each standpipe system may also be fitted with a drain valve. The drain valve is located at the lowest point on the standpipe system. The drain valve is used when the standpipe system has been used, tested, or repaired. Cross connections in standpipe risers must be red in color. The automatic ball drip device between the check valve and the outside hose coupling on the fire department connection prevents water from building up in the piping. An automatic ball drip on a standpipe fire department connection that leaks is an indication that the check valve is defective. This drip device makes sure that the fire department connection is not blocked by water which has frozen in the piping. If water freezes in the piping, the fire department will not be able to pump into the system. 3. Alarms and supervisory signal devices. Supervisory devices are often connected to a central station company which monitors the sprinkler/standpipe system for problems with equipment and when standpipe hoses have been activated. In order to reduce the number of unwarranted alarms, it is important that the central monitoring station is notified when any of the control valves are closed for maintenance or repair of the sprinkler system. Standpipe systems are designed with built-in alarm devices. The most appropriate course of action to take when one of these devices is activated is to respond to the fire alarm panel. Devices and equipment supervised. Standpipe system supervision is commonly provided for 1. Water supply control valves. 2. Low water level in water supply tanks. 3. Low temperature in water supply tanks or ground level reservoirs. 4. High or low water level in pressure tanks. 5. High or low air pressure in pressure tanks. 6. High or low air pressure in dry pipe systems. 7. Failure of electric power supply to fire pumps. 8. Automatic operation of fire pumps. And 9. Fire detection devices used in conjunction with deluge and/or pre-action systems. Water flow alarms. Water flow alarms and fire alarms give warning of the actual occurrence of a fire or other conditions, such as broken piping. Alarms alert occupants and summon the fire department. Any signal, whether water flow or supervisory, may be used to give an audible local alarm. It may also send a signal to a central station company. The central station company will then contact the fire department. Water-operated alarm devices must be located near the alarm valve, dry pipe valve, or other water control valves in order to avoid long runs of connecting pipe. Pressure tank alarms. All pressure tanks used to provide the required primary water supply of a standpipe system shall be equipped with a high and low air pressure and a high and low water level electrical alarm system. This alarm system automatically enunciates the condition of the air-to-water ratio, which should always be 1:2. However, when the water level or the air pressure falls below acceptable levels, an alarm signal is transmitted that there is a problem with the pressure tank. Alarm retarding devices. An alarm check valve that is exposed to changing water supply pressure needs an alarm retarding device. This is required to prevent unwarranted alarms when the check valve clapper is lifted from its seat by a temporary pressure surge. 4. Different types of valves. Check valves. A check valve is a type of valve which only permits flow in one direction. These valves are often designed for safety reasons, to prevent backflow and to ensure that someone operating a system knows which direction water is flowing in. Swing check valves. This is a type of check valve that allows full, unobstructed flow and automatically closes as the pressure decreases. These valves are fully closed when the flow reaches zero and prevent backflow. A swing check valve is normally used in systems using a gate valve because of the low pressure drop across the valve. Alarm check valves. The basic design of most alarm check valves is that of a check valve which lifts from its seat when water flows into a standpipe system. These alarm attachments are designed to initiate an alarm by a drop in water pressure in the standpipe system. The alarm signals to the occupants of the building that the standpipe/sprinkler system has been activated. Curb valves. Non-rising stem curb valves are a non-indicating type of gate valves and are provided in water distribution systems to allow for segments of the standpipe system to be shut off for repairs or maintenance without reducing protection over a wide area. These valves require a special key wrench to operate. A valve box is located over the valve to keep dirt from the valve and to provide a convenient access point for the valve wrench to the valve nut. A complete record should be made for each valve in the system, including date of installation, make, direction of opening, number of turns to open, and any maintenance performed. OS&Y, outside screw and yoke. OS&Y, outside screw and yoke, gate valves are installed at several places in the system. The OS&Y valves are found just inside the building wall on the main riser, or outside in protected pits. The OS&Y valves can be used to shut down just a part of the standpipe system. Sections may be shut down when fighting a fire. Sections are also shut down for testing, repairs, or maintenance. It is easy to tell if the OS&Y valve is in the open or closed position. If the stem is raised out above the control wheel, the valve is open. If the stem is flushed in with the control wheel, the valve is closed. 5. Fire hose, including couplings and nozzles. The care, use, and service testing of these components must comply with the standard of the National Fire Protection Association 25, 2011 edition, and the National Fire Protection Association 1962-2008 edition in order to provide safety for users that the component will perform as required. Fire hose outlet and release rack. At selected locations in the building, the piping is connected to a hose. These connections are controlled by hose valves. No water is allowed into the hose until the valve is opened. The fire hose valve shall only be operated by the fire department. The hose is usually stored on a quick-release rack. The hose at each outlet shall be kept upon a hose rack, firmly supported and placed between 5 feet and 6 feet above the floor or landing. Hose valves shall not be operated for normal testing and maintenance procedures. Inclined hose racks are often used, as most existing stations can accommodate such racks. The rack should be located where the sun or excessive heat will not damage the hose. The rack has the advantage of allowing the hose to drain internally, while providing a drying area from which firefighters can easily load and unload a hose. Hose cabinets and storage. Cabinet equipment identification. Cabinet shall be identified in an approved manner by a permanently attached sign with white letters not less than 2 inches high and a contrasting red background color, indicating the equipment contained therein. Exception. Doors that have either an approved visual identification clear glass panel or a complete glass door panel are not required to be marked. Locking of cabinets shall be permitted in Institutional Group 3 structures. Cabinets containing firefighting equipment such as standpipes, fire hoses, fire extinguishers, or fire department valves shall not be blocked from use or obscured from view. Hose valves are kept with a hose valve cap fastened to the valve with a chain. Storage. Hoses in storage shall be kept out of direct sunlight and in a well-ventilated location. A hose shall be stored only after it has been properly inspected, service tested if required, cleaned, dried, and rolled. A hose that is out of service for repair shall be properly tagged and kept separated from any hose that is in storage and ready for service. To maximize the life of a hose, it should be stored in a ventilated area at temperatures between 32 degrees Fahrenheit and 100 degrees Fahrenheit. Hose houses. Hose houses may be installed on the system. The hose house must be painted red. The house is usually located outside the main water supply grid. The house must be accessible at all times. Hoses, nozzles, and other fire protection tools are kept in the hose house. Standpipe connections are located in the hose house. These connections allow the firefighters to connect directly into the yard system. They are very helpful when the street mains are located too far away from the building. The connections save a lot of time when fighting a fire. Hose outlet valves are painted red. Riser control valve servicing house outlet valves on a standpipe system are required to be painted red as well. Nozzles. Discharge device. A device designed to discharge water in a predetermined, fixed, or adjustable pattern. Examples include, but are not limited to, spray nozzles and hose nozzles. Nozzles on a 2.5-inch hose, except for yard hydrants, shall be at least 15 inches in length and shall have a smooth bore with a 1-inch or 1 1/8-inch discharge orifice. A nozzle is attached at the end of the hose. The nozzle is used to direct the stream of water from the hose. Nozzles at auxiliary hose stations shall be fire department approved, adjustable combination fog nozzles. The hose and nozzle must be easy to reach at all times. The hose outlets are located so that every part of the building may be reached with a hose stream. The maximum length of a single hose line is 125 feet. If the hoses are installed in cabinets, each cabinet should be labeled fire hose. When the hose outlets are not easy to see, signs should be posted, directing the location of the hose valves. Nozzle valves attached to an in-service hose shall be kept in the closed position. Hose records. Occupant use hose. Accurate hose records shall be maintained. Records are essential and necessary data to determine hose performance and ensure safe use in firefighting. Cost effectiveness can also be determined. Each length of hose shall be assigned an identification number for use in recording its history throughout its service life. The identification number shall be stenciled on the jacket or cover using an ink or paint that is not harmful to the hose. The identification number shall be permitted to be stamped on the bowl or swivel of the female coupling in a manner that prevents damage to the coupling. Where hose repairs are frequent, however, couplings and hose links can become intermingled, so that either stenciling the hose or changing the couplings should be employed. In stamping couplings, the proper procedure is to insert a special steel plug with round edges into the end of the expansion ring. One sharp blow from a steel numbering die will then clearly stamp the coupling. Coupling bowls can be damaged by improper stamping. Aluminum couplings should be stamped before they are hard-coated. Some fire departments color-code couplings, as well as various tools to identify the company to which the equipment is assigned to. This enables each company to readily identify and pick up its hose and equipment at a fire. Where mutual aid operations are frequent, each length of hose should be appropriately stenciled or marked with the identification. A water-based latex paint is not harmful to hoses. Paints with a petroleum solvent base can cause the bond between the liner and jacket to fail. Records of hoses used by the fire department shall be kept as part of the fire department's complete equipment inventory. Conditions, repairs, changes, and problems shall be recorded immediately for each length of hose. Records for hoses on racks or reels or in enclosures shall be kept at the hose location or at a control location on the premises where the hose is located. The following information shall be included for each hose. A. Assigned identification number. B. Manufacturer and part number. C. Vendor. D. Size, meaning the internal diameter of the waterway. E. Length. F. Type of hose. G. Construction. H. Date received and date put in service. I. Date of each service test and the service test pressure. J. Repairs and new length, if shortened. K. Actual damage. L. Exposure to possible damage. M. Reason removed from service. N. Reason condemned. O. Indication that the hose has been removed from service or condemned with the warranty period because of an in-warranty failure. Other information recorded may include coupling threads, manufacturer of coupling and part number, length of guarantee, label number, and cost. Out-of-service hoses shall be properly tagged with the reason for removal from service noted on the tag. Occupant use hose. Occupant use shall be service tested within 90 days prior to being put in service. The service testing of a hose is to ensure its suitability for continued use. For unlined standpipes with a trade size, 1.5 to 2.5 inches single jacket hose, the acceptable service test pressure is 150 pounds per square inch. This concludes Volume 4. Repeat each chapter as often as needed until you are confident with all of the material. A transcript of this material is provided for free by the New York City Fire Department. See the link in the description below to upload the transcript and additional reference guides that you'll need to familiarize yourself with in preparation for the exam. Post any follow-up questions in the comment section below. Subscribe to stay current on updates to existing exams and to be notified of new test preparation content. If you found this video helpful, please consider leaving a like. Thank you for watching.